Okay, our next item here is going to go ahead and stray away from the standard form in the shifting and whatnot. And it's pretty common to see this type of stuff in calculus and, math above. That is going to go ahead and require a little bit more of, kind of like a constructive thought or in just seeing things through a different filter here. So, that said, is that we look at this guy right here, and we recognize that it's not the same as an H&K translation. We got other things going on. We got like a polynomial on the bottom there, and we got a variable in the numerator, and so there's a lot of things that are different. So I'm going to show you how to go ahead and tackle these. The first thing that you want to do is that you want to go ahead and factor everything. And I always recommend this, and I'm going to start down here, is that I'm going to take the equation, and I'm going to go ahead and factor the bottom. So I need to say, okay, since it's quadratic, what is going to multiply to a -2 and add to a -1? And those are going to be a -2 and a +1. So on the bottom, I have something that is going to look like this. Okay, so that said, is that I'm looking for the things that are going to go ahead and make the bottom into zeros, because we know division by 0 is bad. Okay, and so I look over here and I look over here, and I'm just like, okay, I'm going to see if I can cancel anything out, like with the top and the bottom, but obviously I can't here. So I'm going to set these equal to 0. And then I am going to go ahead and talk about how these affect the graph. Okay? So I find out that x is 2 and x is a -1. So that basically means is that these right here are not going to be in the domain. And so they're going to manifest themselves as asymptotes. And they're vertical asymptotes because they're x's, and x equals something is going to be a vertical line. So it looks like I have an asymptote here at x equals a +2. And so I put that on the graph right away, and x equals a -1. And I put that on the graph. And that completes kind of like the first step of doing these things out, because I like to, or doing these rational equations out that are not in standard form. So the vertical asymptotes, and I didn't leave myself a whole lot of room, nor you guys, so my apologies, are going to be x equals 2 and x equals a -1. So next step, I like to go ahead and find the horizontal asymptote. And I'll show you how to do that by kind of paging backwards through the notes so we can go ahead and see the conditions for a horizontal asymptote. Okay, so going back through the pages here, we have these conditions for horizontal asymptote. And basically what this means right here, and I'm trying to kind of put all these pieces together using a lot of letters, but let's go ahead and take it chunk by chunk. The first part for the horizontal asymptote, this says if m is greater than n, the horizontal asymptote is y equals 0. Now what that means is that we're looking here in the upper right hand corner that this is m, and this is n and this is m. And so basically what this is saying is that if the highest power in the denominator, okay, is greater than the highest power in the numerator, the horizontal asymptote is y equals 0. Okay, and it looks like this happens to be the case. So let's take a look at how that applies to the example that we're doing right now. Notice that this is the highest power of 1, and this is the highest power of 2. Since the denominator's power is greater then the numerator's power, that basically means is that the horizontal asymptote is going to go ahead and be y equals 0. Okay? We're going to discover why that is a little bit later on. So we just have to follow that algorithm for the time being, and I'm going to put the horizontal asymptote right here. It looks like I'm putting it at y equals like a half or whatever, but I don't like putting it right on top of the x-axis because you can't see it. So I just label it off to the side as y equals 0. Okay, and so before I start going on to the next part, a couple different things about horizontal asymptotes is that horizontal asymptotes predict basically the value of y as x gets really, really large or really, really negatively large, if you will. In the middle here, it can go ahead and sometimes the actual graph can cross the horizontal axis or the horizontal asymptote, because again, a horizontal asymptote only predicts the trajectory of the function as the x gets really large or the x gets really, really negative. Okay, so in between those asymptotes and really, really close to those asymptotes, we might break some rules here and there about crossing the horizontal asymptote, but we never can cross a vertical asymptote. And so let's go ahead and see why that is. So first thing I want to do is that I want to find some X-Intercepts to help me out with the graph. Now, we have this horizontal asymptote at y equals 0, and it would seem like, hey, there couldn't be any. But at the same point, let's go ahead and find out how to find X-Intercepts using this form. Okay, so we're going to erase out the bottom part here, and then we're going to take a look at how to set this thing up. Okay, so the first thing that I want to go ahead and do is that with X-Intercepts, I want to set y equal to 0 and then solve. Now, one of the things about setting a rational function equal to 0 is that the only way to get a rational function equal to 0 is for the numerator to be 0. We don't usually have to worry about the denominator because the denominator here, if we go ahead and we have 0 in the denominator, that's undefined. So the only way to get a fraction to go to 0 is that you would have 0 over whatever, something. That would equal 0. But if you had some number divided by 0, you would have undefined. So we only really have to worry about setting the numerator equal to 0, and we end up with x equals 0, and it kind of solves itself. So I know that the first point of my graph is going to be at 0, 0 here. That's where the x-intercept is at. So I go 0, 0, and yeah, it's right on top of the horizontal asymptote. So we're going to see what happens with that with some strategic points. So, and I'll show you how to set that up. Okay, the y-intercept, basically what we do is that we set x equal to 0, and that is going to go ahead and give me 0 over 0 squared minus 0 minus 2, which of course is going to give me 0. And we kind of knew that already because the only place that hits on the y-axis has already been revealed at 0, 0. So, on to the next part here, they happen to be the same thing. And I like this example because we're going to need some strategic points. You'll probably need a calculator, not a graphing calculator, but a regular calculator to plug some stuff in and kind of see where these things are. And I'm going to break it up right now into 4 different zones where we're going to need at least 1 point to be able to make a prediction of what this graph looks like. Okay, so some strategic points, the way that we want to play it out is like this. And I don't want you guys to go right to your highlighter and start highlighting your graph. But what we need to do is that we need to find out, let's go ahead and just concentrate on this asymptote right here. Okay, and what we're going to do is that we're going to see if a graph is going to exist here or here, okay, which basically means to the left of that asymptote. It's going to go ahead and be either above the y-axis or below the y-axis. Once we plug a point that's to the left of that vertical asymptote, x equals a -1 in, we're going to reveal where the graph is, and we can run with it from there. So let's do that. Okay, so I'm going to go ahead and plug a point that's to the left of the x equals a -1 asymptote, and let's do a -2. So when I plug it in, I'm going to go ahead and get this stuff right here, and that should go ahead and tell me what side of the graph of the horizontal asymptote is on. So, okay, so it looks like when I plug a -2 in, okay, -2, I'm going to get a -1/2 out. So let's go ahead and plot that. So I got a -2, a -1/2. So I know the graph then, as soon as I know it's either here or here, I'm going to go ahead and be able to trace it kind of like this here. Okay, that was not my best. Let's try that again. That's not even that good. Okay, down here. And so I know it is going to go ahead and stay pretty tight to the asymptotes and follow them all the way around. So the next things that we got to go ahead and do is this, is that we want to find out what's going on in between these two asymptotes right here. So here's the deal. It says since we can go ahead and cross an asymptote, we have to go ahead and test some points on this side of the the vertical asymptote and that point 0, 0, and then we're going to have to go ahead and test some points over here to see what the graph is doing. The reason why we're doing that is because we could go ahead and have these combinations of the graph in the middle. And again, I don't want you guys to mark these down. This is just a quality of life explanation. The graph could look like that. Okay. The graph could go ahead and look like that. The graph could look like that. Or the graph could go ahead and look like that. So we don't know. And so we have to go ahead and find some points that are going to help us decipher, again, strategic points that are going to help us reveal what the graph is going to go ahead and be doing in between those asymptotes and that particular point at the origin. So let's plug some points in on either side, and let's see what we get. I'm going to pause the video and do all that heavy lifting, and I'll be right back. Okay, after loading these in a calculator real quick, it looks like this space right here, the direction of the graph is going to go ahead, and it looks like it's going to be trending up as I plugged in a -0.5, which is in between the asymptote and this point at the origin here, and that's going to kick out like a 0.4. So that's a point about right there. So I know that the graph is going to have to head up like that. Okay, and I don't know what happened to my graph down here. We're going to fix that. And notice that I'm also going to go ahead and log the strategic points down below here, just so I know what I plugged in to go ahead and judge where the graph is going to be. So I also plugged in 1 right here, and I got, sorry about that, the iPad cut out, and so not certain what happened there, but last I was talking, I plugged in 1 to go ahead and check this area to see which direction the graph was going to go, and I got a negative 1/2 out. So it looks like at 1 I'm going to get a -1/2 right here, and so I know that the graph then is going down like that. And so almost done here. So I have a good prediction of where the graph exists in relationship to the asymptotes and the intercepts. And so just let me go ahead and log this strategic point over here that I need. And by the way, I picked this example on purpose that it has a lot of strategic points that you're going to go ahead and see the power of them, just being able to predict where the graph is going, in, like I said, relationship to the asymptotes and the intercepts, if you have any. So, last thing to do is just check where the graph is going to exist to the right of the vertical asymptote x equals 2. So let's go ahead and check that out. Okay, so the point that I picked was x equals 3, and I did so because I know that that is going to go ahead and tell me where the graph is going to exist either here or it's going to go ahead and exist here. So when I plugged it in, I got 3 over 4 or 0.075. Or 0.75 rather, and so that is going to go ahead and give me a point right here. So once I get that point, I know that the graph is going to exist something that looks like that. Okay, so you can see it is a very peculiar looking graph, and it takes knowledge of finding the asymptotes. Okay, so being able to find the asymptotes using factoring, and so I'm going to go ahead and just list these off here. Factoring for the vertical asymptotes, all right, and then we have to go to the rules that are delineated in the front half of this notes for the horizontal asymptote. Okay, and then we set the equation equal to 0 and solve for the x-intercepts. We only had 1 at 0, 0. And then we go ahead and plug in 0 to find the y-intercept. In this case, it was the exact same thing. And then, if you can't tell where the graph exists, you need to go ahead and plug in some strategic points, which I did there. And usually you don't need that many strategic points, but in this case, you need a lot of them just to go ahead and see what that looks like. So, at any rate, I'm going to go ahead and show you a picture of what it looks like on Desmos, just to show that everything worked out fine. And then that'll be the end of the example. So, 1 minute, I'll be right back. Okay, so you can see the Desmos workup on the right, and our hand-drawn graph using some strategic points and whatnot, and looks pretty good. And so my grandmother say, "Hey, not too shabby, kid." And so we're gonna go ahead and we're gonna go on to some other examples that have some strategic points and some other algebra tricks involved. But yeah, this should definitely go ahead and get us, started in the conversations of the relationships of asymptotes, intercepts, and strategic points. So on to the next example. That's how you do that, and keep watching.